Good morning. Today I'll be discussing the careers in calculus presented by Leo Bai. The first topic I'm going to cover is optimization. Optimization calculates the absolute maximum or minimum of a function. To do this, it uses the first derivative test to identify an absolute minimum or maximum. In the real world, optimization can be used to calculate maximum volume and minimum number of materials it takes to build something. It can also be used in business to calculate maximum profit and minimum costs. A drug dealer could utilize optimization since the drug dealer would need to find the maximum price that he could sell his product at while maintaining a healthy number of customers. Here is a real world scenario of optimization being in use. Pablo has 200 buyers on the East Coast that buys cocaine for $18,000 per kilo. For every increase of $1,000, Pablo loses 5 buyers. What is the optimal price that Pablo should sell his cocaine at so that he makes the most money? Now here's how you approach an optimization problem. The first step is to write out your equation. So the buyer's equation is 200 minus 5x. This is because Pablo starts out with 200 buyers and he loses 5 buyers every time he increases his price. The price equation is $18,000 plus 1,000x. This is because he initially sells at $18,000 and he increases it by $1,000 every time. The revenue equation is the buyer's equation multiplied by the price equation. And now that you have all three of your equations, you can move on to step 2, which is to use the first derivative test to find the maximum value. This is because wherever the first derivative is equal to 0, that means the original function is either minimum or maximum. So the first derivative of the revenue function is 110,000 minus 10,000x. Now we set that equation equal to 0 and we solve for x. Eventually, you get x equals 11. Now, the next step is to find out if 11 is a minimum or a maximum. In this scenario, I used a calculator and I graphed it and I found out that at x equals 11, it was a maximum. But if you don't have a calculator, you can use a number line to find out if it is a minimum or a maximum. The next step is to plug your x value into your original equation. So as you can see, I plugged 11 in for x for the bars equation, the price equation, and I also did it for the total revenue equation. And on the right-hand side, these are the values that I got. So what do these values mean? These values mean that Pablo will make the most money selling at $29,000 to 145 buyers, and he will make the total amount of money he will make is $3,407,500. Obviously, drug dealing is not a legitimate career, and here are some real careers that utilize optimization. First off, a business owner, because they need to maximize their revenue while minimizing cost. An architect might also be able to utilize optimization since they need to create something with the minimum number of materials and they need to make it the maximum area with the minimum number of materials. The next topic I'm going to go into is related rates. Related rates is basically the impact of the rate of change of one variable on the rate of change of another variable. This, in simpler terms, this means that when one event impacts another event. In the real world, related rates allows us to calculate how fast or slow something is changing. For example, you can calculate how fast the volume of a basketball is increasing when you are pumping it with air. Someone who could actually use related rates is an Aquarius. It's basically just an aquarium worker. They might need related rates to calculate how fast water is draining from a fish tank, or they could calculate how fast the fish tank is filling up with water. Now here's a real life problem that uses related rates. A rectangular fish tank has a length of 10 meters and a width of 4 meters and a height of 3 meters. Suddenly, the water level begins decreasing at zero point 0.5 meters per second. How fast is the volume of the water decreasing? Now, to approach a related rates problem, the best way is to draw out a diagram first. So as you can see, the width is 4 meters, the length is 10 meters, and there's a height of 3 meters, and the height is decreasing at 0.5 meters per second. And in this problem, remember, we're looking for the change in volume, which is dV over dt. So now that you have all your variables and you drew out your diagram, you can move on to the equation. So we know that the equation to find the volume of a rectangular prism is length times width times height. And we're looking for the change in volume, which is dV over dt. Now length and width stay the same because they are constants, and only the height in the equation is changing. So dV over dt is equal to length times width times dH over dt. Now you plug everything in and you get dV over dt is equal to 10 times 4 times negative 0.5. And you get dV over dt is equal to negative 20 meters cubed per second. This means that the water is decreasing at 20 cubic meters per second. A potential career that utilizes related rates is a NASA rocket scientist. Since a scientist observing a rocket launch would need to compare the height that the rocket is increasing at and the angle they need to point their telescope at to see the rocket. A recap of everything I just said. Basically, calculus is measuring the rate of change of things, and it can be found in the world all around us. It can be found in like population growth, and it can even be found in the criminal world. And many careers utilize calculus, like architects, aquarium workers, scientists. Calculus is literally everywhere, and calculus is very important. Thank you for listening to my presentation. If you have any questions, feel free to email me.